Hey guys, welcome to Paul's Maths Labs, and today we're going to be looking at inverse proportion. Now, what is inverse proportion? So, if we were to say that two variables were inversely proportional, so for example, y is inversely proportional to x, we would write down like this. We'd write down and say y is inversely proportional to x, which looks something like this. Remember, k is our proportionality constant, okay? So looking at this, it says y is inversely proportional to x, where k is our proportionality constant, okay? Now, if we're going to look at some of the questions that we may see in some of our tests or exams, or just to get us started off with to understand inverse proportion, we may get a question similar to this one here that says y is inversely proportional to x. Oh, given that y is equal to 12 when x is equal to 6, find the value of y when x is equal to 8. So the first thing first that we want to do whenever we have these sorts of problems is we want to find our proportionality constant, the value of our proportionality constant first, okay? So they've given us some information. They've said that given that y is equal to 12 when x is equal to 6, okay, I'm just going to stop there. So we know that when y is equal to 12, x is equal to 6. And we know that we have a relationship such as y is basically equal to k over x, okay? We know that when y is equal to 12, x is equal to 6, okay? So we've got 12 is equal to k over 6, okay? Now to solve this little equation for k, we need to multiply both sides by 6, okay, in order to get rid of the 6 down here. So doing that, we're going to get 12 times 6 is what? 72. So we're going to get 72 is equal to k, okay? So then if we want to write it down properly, our little bit of our equation, our proportionality, our inverse proportional equation, it would look like this. Y is equal to 72 over x, okay? Y is equal to 72 over x. Now it says find the value of y when x is equal to 8. Okay, find the value of y when x is equal to 8. So we've got y is equal to 72 divided by 8. Now 72 divided by 8 is going to give us what? It's going to give us 9. Yes, it is going to give us 9. So when x is equal to 8, y is equal to 9. Okay? So let's go down to another example. Here it says h is inversely proportional to k. All right, this is mixing things up a little bit. So h is inversely proportional to k. So they're basically telling us that h has an inverse relationship with k. Let's have our proportionality constant. Let's call it a this time. So our proportionality constant on top is called a, okay? So now they're going to give us some information in order to find out what our proportionality constant is. So it says, given that h is 24 when k is equal to 2, we're going to stop there. So these are the key piece of information. Given that h is equal to 24 when k equals to 2, okay? So we're going to say 24 is equal to a over k, which is equal to 2, okay? So we want to get rid of the 2 here. So in order to get rid of that divided by 2, we need to times by 2, okay? We need to times both sides by 2. When we times both sides by 2, we are going to get something that looks like this. 2 times 24 is 48. It's equal to a, okay? And our little equation that we have now is going to be h is equal to 48 over k. Okay, now we need to answer this question. It says find the value of h when k is equal to 8. Find the value of h when k is equal to 8. Okay, so we're going to have h is going to be equal to 48 over 8. 48 over 8 is going to be 6. So when k is equal to 8, h is equal to 6. Okay, let's look at one more example. Oh. So it says z is inversely proportional to the square of w. Okay, that's fine. So we've got a relationship such as z is inversely proportional to the square of w. So we've something over the square of w. Okay. Our proportionality constant, let's call it a for the sake of it again. Okay. So now they're going to give us some information in order for us to be able to find our proportionality constant, which is a. So the information that is given us is given that z is equal to 32 when w is equal to 4. Okay. So that means we can rewrite this as 32 is equal to a over 4 squared. Okay. So let me just rewrite that. I'm going to rewrite it down here again. So we've got 32 is equal to a. 4 squared is what? 16. Okay. So in order to get rid of the 16 here, you need to times both sides by 16. So 32 times 16 is going to give us 512. So we are going to get a is equal to 512. Okay. So there's a new relationship here. We have z is equal to 512 divided by w squared. Now it's going to tell us to find something. So find the value of z when w is equal to 2. So find the value of z when w is equal to 2. So we've got z is equal to 512 divided by 2. 512 divided by 2 is 256. Yes, 256. So when w is equal to 2, z is equal to 256. Okay. So very, very quickly, guys, one more time. When looking at inverse proportion, we are given this sort of relationship, okay, where y is inversely proportional to k, which was our original proportionality constant, divided by x. Okay. And then from there, most questions, they will give you enough information in order to find the proportionality constant first. Okay, so here, for example, the first question we got, it said given that y equals to 12 when x is equal to 6. Okay, so you stop there. That's enough information to give you in order to work out the proportionality constant. And we plugged it in there. We basically said 12 is equal to k over 6. And then we solved the little equation here for k, and we found out that k was equal to 72. And then we rewrote our proportionality equation, shall I say. So y is equal to 72 over x. Okay, then now it asked us a question to find out what the value of y was when x is equal to 8. So again, we just substituting our values into the equation. So we had y is equal to 72 divided by 8. And that just gave us 9. So when x was 8, y was 9. Okay, guys, so this is inverse proportion. It isn't that bad. It isn't too hard. I hope this video has been of some help to you. It's been like a revision or a reminder of how to do it. Yeah, thank you again for tuning to Paul's Maths Labs, and I'll see you guys later.